Okay, this is question 11 from Further Maths 1, exercise 5a. And I'm going to solve this question using the vector projection and scalar product method. It's not the only way of solving the problem, but it's quite a nice way of doing this. So you can read through the setup there. Small ball, mass 2 kilograms, moving in the xy plane, collides with a smooth fixed vertical wall which contains the line y equals x. The velocity of the ball before the impact is 4I plus 2j meters per second. The coefficient of restitution between the sphere and the wall is 1/3. Find the velocity of the ball immediately after the impact. So there's my diagram. U going in, V going out, two components, A and B. The wall y equals x I've written down then as the vector I plus j. I suppose technically it's infinitely long, so I could have put a kind of, oops, I haven't got a pen selected there. I could have said it's ki plus j if I so desired. It doesn't really matter, maybe that's better. But nonetheless, I want a unit vector in the direction of that wall, so that will simply be the magnitude, which is √2. So therefore, divided by √2, I get the unit vector p 1 over √2i plus 1 over √2j. And the other vector I'm going to need is the perpendicular, which is this one here. And I want a unit vector in that direction. And because I'm going to project this velocity into this direction and indeed this direction, I've got to make sure that I choose the perpendicular vector that's going into the wall like this, which is going to be 1 over √2i minus 1 over √2j. And again, how you get that perpendicular, the way I do it anyway, is I basically just think about rotating this vector here by 90 degrees that way. And that will just consist of swapping over, in fact, the components for I and j, which in this case they're both 1 over √2 anyway. And then I can look at this and say, right, well, to go into the wall, I need the I component to be positive in that way and the j component to be negative. Hence how I come up with this. And I've also noted on the diagram that my velocity vector v will simply be whatever a plus b is. And we're set to go. Okay, so let's continue. I'm going to work parallel to the plane and perpendicular to the plane. I've just split the page in two actually. Maybe I can do it like this. Okay, so what I've said is that the component A will simply be this projection in this direction. So A projected in the A will equal the projection of u in the direction P, which if you refer back to what we did yesterday is simply going to be this. So I found the scalar product, I found calculate the scalar product, I have then written the unit vector p, and so I found out quite simply that A was going to be 3i plus 3j. So just follow the steps through there, no problem at all. I'm going to post another video up on this whole process so you can have a good watch of that. Working perpendicular to the plane, then what I'm going to get is that the component B will be minus E times by the projection of u into the direction of this perpendicular vector, unit vector p. Okay, there seems to be some noises outside at the moment. Okay, so again, I've just gone through, filled in the various component parts, taken my time, calculated this all down, and I've ended up with b was equal to minus 1/3 I plus 1/3 j. And then last but not least, I've said that v is equal to a plus b, which comes out to give me this, which is indeed the correct answer. So let me just try and zoom so we can get the whole working in. You can pause on that screen or otherwise. Can I get it? No. Yes. There you go. I'll put the transcript for this up as well. And then parts B and C I think are quite straightforward. But if any help is needed, then of course people can ask me about that.